Hi everyone, welcome. Today we're going to be doing Leetcode problem number 101, Symmetric Tree. So the problem states, given the root of a binary tree, check whether it is a mirror of itself, i.e. symmetric around its center. So the symmetry would be such that the child, like the right child of this node, should be equal to the left child of this node. So this tree that they're showing here is symmetric, and this tree isn't, because this if it would be symmetric if instead of this being the right child here, it was the left child here. So a way we can do this is by basically putting all of the nodes into a queue and then essentially checking two at a time and making sure that they equal to each other. And the way that we the order that we put them into the queue obviously matters, because we want to be putting in the left child of one side of the mirror and then the right child of the other side of the mirror, so that we're comparing those two to each other when we take them out of the queue. So let's go ahead and let's use a deck for this. So I'm going to import collections here, and we'll go ahead and say q equals deck. And then we will, for the first iteration, we want to actually append the root twice, because since we are taking out two at a time, we just want to take out the root and itself instead of the root and then the first child. So we'll do q.append root, q.append root. Great, and then we will say while the length of q is greater than 0, there's a few things we want to check for. So the first would be if one of the children is null. So let's just first pop out the first two nodes in the queue. So let's say q.popleft, and we'll do that twice. So node 1 and node 2. And so a few situations here could occur. One could be that one of them is null, right? So if node 1 is null and node 2 is not null, then we have a false, it's not a mirror. So let's say if node 1 and not node 2, then return false. The opposite could be true too. So if node 2 and not node 1, return false. If both of them are false, if both of them are null, then that's fine. But we want to just continue in the while loop, because there won't be anything to add to the queue. So we'll say if not node 2 and not node 1, then continue. And then if both of them exist, that's when we can go ahead and add their children to the queue in a very specific order. So once we get to this step, it has gone through all of these checks, so that means that both node 1 and node 2 exist. So we'll go ahead and we'll say q.append node 1.right, then we want to append node 2.left. Then we want to do the other side, so q.append node 1.left, and the mirror should be node 2.right. Okay. So this will go through and check a pair at a time and make sure that they are equal to each other. So the one other thing that we need to check here is whether or not they're equal to each other. So if node 1 does not equal node 2, return false. And I'm just going to go ahead and say node 1.val and node 2.val, so we're comparing the actual values. Okay, so this should check everything, all of the different scenarios, and then if it passes all of those, it'll go ahead and append all of the children in the correct order. So once we go back through the loop, we're going to be popping off these two. So we're going to be looking at node 1's right and node 2's left, okay? And if we go through this whole thing and none of these if conditions, that would return false are met, then we can go ahead and return true. So let's just run that and see if that works. Okay, and it works for our first test cases. Let's see. Oh, and it does work for all test cases. Okay, great. So that is how you solve Leetcode problem number 101, symmetric tree, with a breadth first search approach. This is using a queue, and the runtime here would be O of n, the time complexity because we are traversing the tree once, and the space complexity would be additional space required because we are creating that additional queue data structure, so we may have to insert every single node in the tree, and so that would be O of n as well. So thank you for watching, and I hope that helps.